Excuse me. Jeez. Get this chat open. Do we have 2 running? That's amazing. Ha ha ha. 2 bull terriers running. All right, let me kill one of them then. Excuse me. Good stuff. Just one. Keep one running. Yikes. Wait a second. How do I... get out of here, Franker. There we go. All right. So while we're waiting on some people, I'm gonna look through this and ensure that we've cleaned up a little bit. Let's go ahead and create another folder. I call this collections. Remove array 3 there. Excuse me. Allergies or something. Sheesh. We'll move array 3 there. Is there like a resharper? I wonder if there's like a community, but I don't think there is. I don't think you can. 30 day free trial. Maybe I should do that. I should do that. I am. I'm going to use the free trial. I know some of these guys, I think, still. Let's see if it runs out, they can give me a like a 60-day. I've done that a few times. Compatibility limitations. Let me. I love ReSharper. So if I can get it for 30 days, then that's awesome, actually. All right, let's we can really just call this guy buffer because that's pretty much what it is. We're gonna use it in our pool. And we'll make it a class just well. I feel like we could make this, just make it a class for now. We're not gonna pass it around. We're not gonna, it's just gonna be, it'll probably promote it anyway because of it being part of the pooled buffer. Excuse me. And we're gonna make it a T. I think we can use where T is a value type. Do we want that though? I think so. I don't know if that necessarily matters. Might not put any restraint on it. And allows copy and reset. So let's see. So we'll make our buffer. It's gotta accept we'll say size. I think C. I can just use C as a shorthand. This is a fixed size. I'm just gonna put this as a fixed size. I don't wanna get too much into constraints because those might change. It's one of those weird things where I wish that you could somehow I'm having a hard time today, man. Can you It's crazy because non-template parameters such as trying to figure out I don't think it's possible. You can't supply constants. They're not like I don't think they're C++. Yeah. Okay. So I was just making sure because it'd be awesome if we could supply the size at compile time, but it doesn't seem like that's possible. So and we're gonna make it read only. I'll just call it buffer. And buffer storage. And then we want to set buffer equals to new T size. And we're going to give it I guess we can give it a count because we will need oh, we can initialize this in the constructor just to be consistent. The current, well, I'll say the index of the next location. And then we'll add a public int count, and the get will be return index. So index is going to give us the current number of elements pushed into the buffer. See how this is. This is basically just an array wrapper that's gonna give us kind of a one-way ability to add things, and then an ability to pretty much call clear or reset. I guess we should probably call it clear. That makes the most sense to me. Although clear can imply some semantics that don't actually exist. Since we aren't actually clearing anything, we're just resetting the index. Because that's the whole point of the structure, is going to be to cut down on basically we're going to have our geometry, which is going to be like a pooled buffer. We're just going to have our geometry, and as we add geometry, new geometry and vertices to our eventual mesh, we're just going to keep these long running buffers and until we need to draw something else. And then when we draw something else, we'll just reset all the indices and we'll just start drawing over the top of the old stuff. And that way we just reuse this memory. We reuse it to the best of our ability, and that way we don't have to worry about garbage collection, churn, or heat pressure, or any of that stuff. Well, hopefully not heat pressure, although this will be pre-allocated and sitting in memory. Hopefully this it will save us more than it's going to cost us. So let's see. So let's call it push, I guess, because we technically are pushing it. Our insert, our add. Let's just call it add. We want a T element. Is there a throws or an exception? How do you document exceptions here? I'll look up that in a second. Actually, we can do it right here. We'll just see list add, or maybe at. I don't think there's any exceptions thrown here. Maybe if you try to add like a null or something. Well, that's terrible. Is that really the? Doesn't even have legit XML docs. Never mind. Okay. So adds a new element to the buffer. Throws an exception. There's an See, there's no, huh. That's interesting. Maybe it goes in remarks or something. I don't know. We should probably also add a side. Just we'll just call it max capacity, and we'll return buffer dot length. Oops. Actually count is equal. Max capacity, period. What's up? So kind of just to go over brief description of kind of what I'm doing now. Is I'm gonna take. I'm basically, if you remember yesterday, we had our geometry pool, and we have these arrays that are all allocated to these max sizes, and then we have a count or an index for each one of these things. And so what I'm going to do is just abstract out the. There's really no point for us to have to keep counts of all this stuff, and in fact, I think it makes it slightly confusing. But having a structure that will allow us to kind of copy these things, I think will be helpful. So that's what this buffer is that I'm gonna make right here. It's basically just gonna let you create a new buffer of a size, and I think we absolutely do need to keep it as in the heap, because I worry about it on like blowing out the stack. Maybe it won't, but anyway. So this add is as simple as good, man. Good. Yeah, I'm telling you, that's a really neat approach to programming, because it gives you, it's not just like, hey, here's hello world, right? And then you have to come up with like, well, what do I do next? You have to like come up with that in your head. I like stuff like that because it just gives you a ton of things that you can do in the language. And then as you read through, you're like, hey, that's interesting. Oh, that's interesting. And then you start like formulating these ideas of how to meld these things together and how to make them work together into something that could actually be useful, right, for you, or, you know, just as an experiment. You just start to formulate ideas better if someone's kind of giving you the components ahead of time to do cool things. And you'll run into trials along the way, I'm sure, and what works well with others. And I personally like that approach. I don't think there's a one size fits all method for learning languages, but that's a good way to start, I think. So I'm glad you found that useful. If I find any more, there's a few out there that are like, one of them I think I saw recently was like, I don't know how far that one goes, up to 2,000, I think. I don't know, but I feel like there's one out there that's got like 8,000 recipes or something. It's insane. All right, so at this point we're just gonna at this point we're just gonna check to make sure our index is less than our max capacity. Actually, we're gonna check to see if it's greater than or equal to. We're gonna throw a new index out of range exception. And we're gonna say we're gonna cite index. Or we're, yeah, index. Unable to max capacity. Then we'll just add max capacity here, and we'll just call it a day. Okay. So we'll throw an exception there. I think that's a good hard exception to throw. Some people don't like exceptions. I'm one of them. I don't really like the entire throw exceptions everywhere for the sake of handling them. I would much rather use like a Boolean return or a valid return, kind of like functional languages do, versus like throwing. But there are times when throwing exceptions like this, this is basically an assertion. Like, we just never want to go beyond that length. And if we do, something is tragically wrong, and we need to basically halt execution and, you know, kind of pinpoint where the problem was. And that's what this exception is going to be for. And at this point, it's really easy. We can just basically index plus plus equals element. What's up? How's it going? Can you guys? Okay, good. I don't know if some of you are on mobile or whatever, but I constantly am looking at this stream and trying to figure out if it's even visible. I tried using, basically I'm using open broadcast software or open broadcast or OBS or whatever, and they have a scene switcher that I had used. And actually I'm trying to think how to make it a little bit nicer, but basically I have a zoom. I'm gonna show you guys just so you can see what I'm actually. Hold on, let's see. So we could do creative zooms. We'll see if we can do this. Current mouse position is 383,108. You guys could tell me what you think, or if you care or not. I think you probably will. See where I am here. This is 1904, 1113. And actually, give me a second. I gotta change. There we go. Okay, so this is essentially what I have. Is I have a scene switcher that is supposed to. Doesn't look like it's doing it. Huh. There we go. That's what I want. So I had it like this, and I think this is nice. But here's the deal, like, and you're gonna notice this right here. So if I'm down here and I type in, but you see the code completion window pops up. But if I go back into zoom mode, it disappears. Now it's still up for me. I could still see it, but you guys can't, and I think that's kind of annoying. So I'm gonna turn it off. Because I think it's important to see the code completion. I don't know why I can't capture that, because the zoomed version is actually a window capture, and for whatever reason that window is not included in the. Anyway, so you guys see this is all this is doing. Now, I'll be honest. I just had really a thought here. I don't know if I want to add this check to be truthful. I kind of want this thing to be as fast as possible. Now, this is not an expensive check at all. We will come back, because here's the thing: is I'm pretty sure that if I access anything out of that, I'm gonna get an exception anyway. So let's you know what? Let's just do like a small test here. Let's just do a really small test, and I'll just do int array a equals new int, and we'll just do 3. And then I'll say a4 equals 150. Yeah. Okay, so I'm gonna get it out of range anyway. So you know what? Let's remove it from my code, because it's gonna propagate. If I do this and it's bad, it's gonna give it to me anyway. It's gonna throw an element anyway. I mean, it's gonna throw an index out of range exception anyway. I'm gonna call this clear, although maybe reset is better. I think it really needs to be clear. Well, I'm gonna make it clear, because that's kind of the common approach. Why everyone asks that question, and I always my returning question is always, why not C#? I mean, I'll give you 100 reasons why, but I want to hear why you think C# is not a wise choice. I mean, I'll be honest with you, like C# in terms of a language or a runtime for games has been fairly normal. Unity. Why not? Okay, so I mean, yeah, that was going to be my point. But see, the thing is like Minecraft should be proof enough, you know, that any language is viable. You know what I mean? Like it's I'll tell you exactly why. For this for the reason of the stream, to not be esoteric and difficult to follow. Managed languages typically are easy to follow, and they have clear syntax and semantics a lot of times. And this isn't necessarily like an educational stream, but it is kind of, because all of this stuff is going to be open source. It's, you know, we're trying to invoke discussion about stuff. Truthfully, I don't feel like dealing with memory management. Yeah. I mean, I guess the point of all of that is that Minecraft is really kind of a testament to Java graphics. I mean, I don't even think people even. I would have. I mean, Java to me is it's the server. It's just a server side beast. I mean, it's like you just don't even really think about writing a whole lot of client code in Java. Kind of completely off topic. I hold on one second. I do have to take this. So anyway, I mean, like Java is a very educational language too, in terms of like, you know, picking things. I mean, it's much more like educational than like something like Scala. Anyway, no, I'm not trying to be. I just want to make sure that that you understand. I'm not trying to be a smartass, but I that is one of the like most asked questions in this channel, and um, I've prototyped this entire thing in C++. I mean, I have basically I was a professional C++ developer for like 5 years, and then I've just recently taken a new job, and we're doing a lot of C#. So for me, it's kind of a refresher course on C#. It's a way to kind of like resharpen some skills, because I haven't really messed with C# since like X and A. I've done a little bit of Unity, but that's it. But I prototyped most of the stuff in C++, and that way I had kind of like a prototype to follow for this stream. I'm not exactly. Golang. Table flip. The quotes are pretty crude. I warn you. Boltorius is written in Go. He's a Go bot. He's my Go bot. Excuse me. Man, I am struggling. It's like allergy central over here. Yeah. Here's my awesome Go. I used to have an Overwatch plugin here that would pull ranks for Overwatch, but it doesn't anymore. Oh, it's sad. I like Go. I like Go. Okay, I haven't really explored in depth the huge perks of Go, but I like it. I find it hard to find situations where I go, I know what I'll do. I'll write this in Go. You know what I mean? Anyway, so kind of off topic was a very, very, very slow, methodical. We could do some functional stuff. I disagree. I think that object-oriented programming is going to always, well, at least for the next 20 years, will have its place. The problem with functional programming is the relation to actual language and natural language. Although it has elements that are way more natural than object-oriented programming. So there's the arguments both ways. I think having both of them available is an exceptional advancement, to be honest. Because functional was kind of retro for a while, and then they've really, really done a good job of bringing it up to spec. And then they've also done, object-oriented guys have done a great job of bringing, OO languages more to the functional syntax sugar, more easier to write, clearer to understand, that sort of thing. We're going to call this clear, although what we're going to really do here is not clear it. It's just going to, we're just basically going to set index to 0 is all we're going to do. Sometimes I don't like interviews, to be honest. I don't like interviewing people. I tend to have a natural tendency to give people the benefit of the doubt. So when they're completely full of shit, I look like an idiot at the end. So I just don't like being hard on people. I myself hate interviews. Like I hate being interviewed, and so it's kind of natural for me to be easier. I have colleagues that are awful, and I always end up like letting them be in the interview with me to ask the hard question. Yeah, just be honest. The worst people are the people who lie, man, or just say that they know a lot of stuff and then they don't. Like, it's so much easier. Like, it's just so much better for everyone if, I mean, this is a very general and kind of not important. I mean, in general, you can get an idea of how it works, but basically, just like don't fudge your experience or your knowledge. Just be honest about it, because employers will not only look to see like if you know your stuff about what you say you know, but when you get hired, they're gonna expect you to actually do some of this stuff. And if you can't, or if you take a really, 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 really long time to execute it, it normally doesn't last very long. I would just put as many resumes out there as possible. I'm just gonna go out on a limb, and there might be some people who disagree with this, and say try to avoid headhunters, because your degree is going to be good enough to land you a job somewhere, and you don't need the help of a recruiter. You're in a great position to find a job by yourself. You do not need a recruiter. You're going to take a huge pay cut if you let a recruiter refer you to a job. And I would just say stay away from them. This is coming from a guy. It's hard for me to tell you this because I have a lot of friends who are tech recruiters, and they would kill me. They knew I was referring you away from it, but it's true. I mean, you're in a field where you're very sought after, so you need to use that to your advantage. And I would just throw out resumes, man, and don't be too picky. Take something. I don't want to say take anything you can get, but take a job that gives you an opportunity or a segue into another job. Oh, that's awesome. Just don't be too picky about what you do at first, because it's going to be experience. And I will say that experience and relationships are the two biggest ingredients to success with computer science. If you burn bridges and you don't establish relationships, you don't network. Like the job. Okay, so here's a great example. So I worked at a small kind of startup that did Flash-based like MMO games, and it started right after like Club Penguin was successful, and Disney bought Club Penguin from that smaller company. I can't remember what they were called, for like $30 million or something, and it sparked off like this entire like race to create all these virtual world games in Flash and stuff like that. So they were hiring a bunch of people. I didn't know a whole lot of Flash or a lot of ActionScript, but I kind of like learned it, in my spare time, and I just threw out resumes to random Flash companies. Anyway, they picked me up. I met over 5 years or something. I mean, countless people, junior programmers, lead programmers, CEOs, just all types of just like, because we primarily did client projects. So like we did a Ubisoft project, we had Viacom projects left and right. I mean, I'm not even talking about those type of relationships. I'm just talking about work relationships. What's up? If you just maintain good work relationships, so the current job, so when I was at this startup at the very beginning of my career, we had a junior programmer, or an entry level junior program, whatever his title was, I don't know, but the guy was super smart and clearly exceeded his junior programmer status, in my opinion. But anyway, like I had a I guess like I would call it a friendship, but just more than anything, just respectful, I guess, of him. And I guess not a lot of people at the company were. I don't really know, but that guy is basically I'm trying to think of what his actual title is. I guess it's not CTO because it's not of the entire company, but it's basically the studio tech director. He's the technical director at the specific studio for NCSoft. And I, reached out to him and was like, "Hey man, how's it going?" And he was in that position, and like immediately it was like, "Just come work for us." It's like that sort of stuff. It's like here's a guy who is basically, he's like 4 or 5 years younger than me, and he left that startup that we worked together at, and he literally just climbed the ladder just straight up. And then he reaches out a couple years later. Is like, "Hey, look, we got this. You interested?" It's. I mean, I probably couldn't have gotten the job on my own. You know what I mean? Maybe I could have. I don't know. Well, he gets in there and he networks and he meets people and he understands. He's also super good, man. He's super talented. Oh man. Do they not let you? No, it's your English is fine, man. It's actually pretty good. Yeah. Sorry, I didn't mean like that relationship. Do they not let you use your CS or your education in military? I mean, it seems like that's like basically in the U.S. if you have a college degree at all, you like are automatically promoted to officer. um so anyway, that link that I gave you guys, yeah, let's dodge any empirical government and political opinions. Let's keep it clean in here. So we have our clear, we have our add, and then we want one more, which is just going to be a copy to. Oh, how do we do this? I suppose that the best thing we could do is just create an out. or destination. Yeah, let's do that. Copy creates a new buffer. Now, we're getting there, dude. We're getting there. Real fake doors. God. We're getting there. I want to know, so do I gain anything from this out parameter versus just returning a T array? I don't think that I do. I don't think this is like in C or C++, you would use a pass by reference here and maybe like a Boolean return or something, because you don't want to, because basically anything that you pass in, you're going to, including returns, it's going to copy it on the stack. So you want to avoid the copy. But I think with arrays and the special circumstances there, I can just return a T array, can't I? So Shishendu, basically, a lot of practice, a lot of reading, and then actual experience professionally writing engines. To be honest, like that's. I had two classes in college that I will say kind of, they didn't give me the actual knowledge of how to do this, but it kind of preps you for the things that are involved and the systems that are used. But I took 2D and 3D game engine programming. Those were actually classes. Right. So I took those classes, and then when I got hired, they really needed a lot of work on an engine, a specific 2D. It's like an isometric engine. And I kind of just took what I had learned from school, made a lot of mistakes, and had to make corrections and stuff. But none of this stuff ever starts out really clean. I would say that the reason why I've kind of been making fairly clean progress with this is because I've prototyped it before. I've built something that kind of looks similar to this, and so I'm not exactly just like creating this thing off the cuff as I go. I want to make that clear. Like, I think that programmer ego is definitely a real thing. I definitely have a little bit of a programmer ego, but I feel like that doesn't help people, and it's okay to be a little bit of a showboat every now and then. I mean, you gotta get a leg up somewhere. But for our purposes here, I have no problem. I need to be clear here that, like I said, I prototyped this thing. I've spent time outside of this stream thinking about this exact same thing that I'm implementing right now. So it's not just me just coming up off the cuff. This is coming from about 11 years of professional experience, and then like probably 20 years or so of just programming experience. Answer the question. I just need to know, like, is there any difference? Is there any difference in this? I mean, I know that semantically there's going to be, or like maybe I could just do this, copy, and then returning the array versus and then basically what's the difference between this and then we can do an array copy, source is going to be buffer, destination array is destination, and length is going to be index. Yeah. No, that's what I mean. I don't know if it does or not. I don't think it does. I think it passes all arrays by reference or by pointer, I guess. I guess we can see, right? We can probably tell. Well, if you saw some of the inner workings of this stuff, you would realize where the math. You would realize the math involvement. So this is one thing. We can do this, or we can do this. Let's create a new T array. Copy equals new T index, and then array copy. And we'll copy from, again, the same thing, buffer, this, copy, and then index. And then return copy. Easy. Easy. Actually, does array copy return anything? No, it doesn't. Okay. That's fine. Let's maybe we can see, shall we? Let's build this. Then let me open .peek cuz it's awesome sauce. Okay. I mean, I thought so. Yeah, it's a class. Yeah. Okay. Good stuff. All right. All right. I don't. Yeah, there's no point in this. Although I do kind of want to see. So let's just drop this in here. Actually, I think this is already the same thing. Collections, and here's our buffer. Let's check this out. Check out the IR involved in this. Let's see, copy and copy to. So here's copy to. And here is copy. Why does this look so... I mean, they're about the same. I'm trying to figure out where... This actually looks less. This has a branch. Where is this? I don't like this. I don't like this right here. That's a weird branch to have. Like, it doesn't seem like that serves any purpose. I don't know why that wouldn't be optimized out. Other than that, though, it's basically the same thing. I like, I don't know why I like this better. I just like this better. This just feels better. I don't really have a justification, to be honest. Except for it doesn't branch, but it probably will once we add the use case. So, let me see, what is list? What do like list and that stuff? What does it have actually? So let me just see what like. Let me just make a list. Private list. And oops, I'm gonna end up deleting this. But like this has a copy too, right? Copy. Oh shit. Just do what I'm asking. Copy to. So this has a copy to, and you just straight up provide an array. You don't even have to provide an out. I think the out parameter though implies that it's going to create the exact amount of space you need, and this actually just has a copy. To array. Oh, let's see. Oh, this is probably this is actually probably what we want, and I'm gonna copy them and use this API because so clearly my my gut here was not as it's not as tuned in as I thought. Destination, and then we'll return destination. Okay. Constrained to the count containing all added data. There's no parameter. Okay, so here's our little buffer class. So let's go back in here to the pooled geometry, and let's replace this stuff. So private, and we're gonna call this buffer vector3 vertices. Oops. Equals new buffer. It needs the buffer vector3 max vertices. Okay, so we'll replace that. We'll replace this. Vector2 UVs. Was new buffer vector2 max verts, and then this last one can be buffer vector3 normals new buffer vector3. So all we've done here is we just replaced these arrays that we had. Buffer storage. We've just replaced these arrays with our new buffer, and it's gonna clean up some stuff a little bit, and we also want to have this as well. It's just gonna clean up some of the code. We'll no longer need to maintain we'll no longer need to maintain separate counts for all these things. We can just have single buffers that handle all that stuff internally. It just cleans up the code a little bit. It's not really like something that we needed that was necessary. Good, dude. How you been? Wait, 2,000 lines? Where? Where did you see that? Does it say that somewhere? Do I have like a line count or something? That'd be awesome. So once we've done that, we have to actually So this is slightly confusing. So the last time, right before we left, there was a few bugs. We had a few bugs. We had some flipped vertices. We had some weird triangle index problems. We had a bunch of other stuff. So I normally don't do this, but since that issue was a little bit weird, I looked at it a little bit last night, and I probably could have done it on stream, and it wouldn't have been a problem because I tracked it down pretty quickly, but it could have been something a little bit more sinister, so I didn't want to risk that and just sit here and waste like hours of time trying to debug that. So I just went ahead and figured it out, and I probably could have gone through the fix here, but I'll go through and explain kind of what's going on. So we want to keep a triangle count because this is important, because the triangle counts basically for every quad you have 6 indices, and those 6 indices point out how to draw the triangles, which is like basically one vertex, another vertex, but between the quad it only has 4 vertices. And so basically we have to track 2 counts, and that's what this is the motivation for this buffer, is we want to keep a separate triangle count, but we want the actual index for the triangles to be internal to this buffer. That probably doesn't make a whole lot of sense, but you'll see what I mean in just a second. Total our tally index for triangle. Actually, we'll just do this. Triangle index tally. Okay. So we need to update our actually this is like a scratch list, and we probably trying to think if we even I guess we do, because we're gonna write all this stuff early, and then we'll yeah let's do this. We'll just call it triangle indices, and it's gonna keep basically the current triangle indices for that specific quad as it relates to the entire geometry. Per quad. So for each quad, we're going to come in here. What we do is kind of tricky. We store the current triangle count here, and then that's going to be our running index. And then what we actually do here is we're going to use the indices. Now, really what we could do is just do plus this, plus this, plus this. Like you'll see basically what we end up doing is we probably don't even need this. We don't. We definitely don't need this. Okay, let's just not make it as complicated. So triangles, push or add. We have an add, and then this element's going to be try count plus 0. And I know that's redundant, but you'll see why in a second. We need 6 of these, like we have down below here. And then it's going to go 0, 1, 2, and then 2, 3, 0. Now that's just the order that I have these vertices already sorted. So based on the pre-sorted order of the quad vertices, this is the order in which I tell the GPU to draw the actual triangles. And then our triangle count, and actually this needs to be triangle count and not try count. And then we add 4 because there's 4 vertices. That's it. Done. Then we get rid of this. Okay, so I mean this is about the most complicated piece of the whole thing, to be honest. Yeah, that sounds pretty daunting. So this 2 mesh will need to change a little bit. So we'll just have verts. We don't even need to create this. This is going to be actually how we do this. I think we can actually do this. I don't even think we need. So let's say I think vert, we just do vertices to array and then equal UVs. This is calling our buffer class again. This is getting the array from our buffer. Rules to array. So we stored a bunch of stuff in the in our buffers, and then this is just actually dumping all of what we stored into an array. And then here we need to actually reset our clear. We'll clear that, and then UVs.clear, and then which one? Normals, not clear, and triangles, not clear. And that just resets all the counts. We need to update a few more things because this is going to be So vertices we'll add. We'll do an add here, and we'll do vertex. UVs that add, and we'll do UV, and then normals that add, and then normal. And I'm going to rename this to add vertex just to keep a convention here. Actually, I have all my public methods right there, so this is I'm gonna do a pass by reference here. Just to ease the copying that occurs with vector2. So let's do ref vector2, and then let's just call this target. So what we'll do is we'll do target.x and then target.y. Since we're passing by reference here, we're just making, it's just mainly a utility function here. That could almost be meh. That's fine, whatever. So we'll keep a we'll just keep a UV coordinate out here, and we'll do apply offset, and then we'll just pass this as ref here. It really could just be, oops. Actually, we call this vert UV, so let's do that. And then we'll just apply offset and then reference vert UV. And then that way we can, yes, I like it. Apply offset. Wait, why is this irritated? We'll change it to out. It's bad because it's uninitialized, and it expects that to be uninitialized. And out is for actually supplying. Okay, so we've actually reduced this a good amount. I'm actually pretty happy with this for right now. We'll get into more stuff. So if you remember last time, kind of what we did is I mentioned that there was like a is back. There was a hack in there. Basically, I just went through and I reconstructed how the quads were created and the ordering in order to basically in order to get all sides of the cubes to orient themselves correctly. And this took a little bit of, this is what I was most concerned about, but I basically just figured a quick way to resolve that, and that fixed a lot of problems. The other problem was the triangle count thing. We had some messed up logic in Geometry Pool where we were using triangle count and triangle index kind of interchangeably, and that's not really what you're supposed to do. Because the triangle indices, there's 6 of them, or there's 6 vertices, or 6, so excuse me, there are only 4 vertices, but we need 6 indices to pass to the GPU to tell them which, between those 4, how do we draw two triangles. And so in order to do that, you need 3 vertices to draw one triangle and 3 vertices to draw the next triangle. So 4 vertices makes 2 triangles, and we have to give the index of each vertex in order to supply the GPU with drawing instructions. So that's what this is. But what we ended up doing is incrementing this by 4, so it was putting the index all out of whack, and we were getting weird. Results. Okay, so the other thing we did was just to run a quick test. We went in our main class, and we have this dummy mesh here. We're calling a chunk mesh, and then we create a chunk. And what I did was basically just say, for every location in this chunk, let's just make it dirt. And then I have like a quick hack here that calculates the UV of our sprite sheet. So our sprite sheet is from Sphax PureDB Minecraft skin pack, which I love, by the way. And so I'm just going to use this as a sprite sheet for now. And then this just calculates the entire width of the image is 2048 by 2048. 16 pixel, or sorry, let's see how big the pixels are. That's 2048 by 16. It's got a tile width of 16, so it's 128 by 128 pixel textures per block or per side. So the math involved here is actually pretty easy. You just figure out what is the width of a UV cell, and we know that height and width are the same. And so the UV cell basically becomes, you need to make it a percentage. So 2048 divided by 16, and then figure out the percentage of the entire thing, which I guess actually you could simplify that if you wanted to. Algebra 2. And then we pick a location. So the location is going to be like, this is 215. And so you have to, I think you do it from the bottom. So this is 0, 0. So 1. So 0, 1, 2. Right? So 0 indexing. 2. And then 15 is all the way here. 16 would be out of bounds. But 15 is here. So 0 index. So you start from the bottom, you go over a certain amount, and then up. Yes, I'm using I'm using GL for Sharp. It's let me give you a link. Really like it. The guy is super cool and also has a really nice Voxel engine blog. He also has an. I will say that one of the main reasons that I picked this thing is because he also has a GUI library that fits in. And this is, by the way, this is not the most prominent. This is like not the most prominent pick for C# binding. I think there's one called like. I can't even remember the name of it, but it's a lot more popular. But this guy had his own like Voxel engine blog and did this for that sole purpose, and so it kind of just made sense. You know, I mean, that's what we're building, so let's follow along, kind of in his footsteps here. And it's a really good wrapper, and it's got a good set of math utilities and stuff, and so I like it. Personal preference, I guess. So we're doing a little bit of hackery in here because we don't want to write some extensive tests here. We just really want to show that our renderer is capable of handling a textured chunk. And so we just basically, we come through here. We don't even optimize. We're rendering all sides of all blocks inside this chunk. And we're passing it to this pool, this geometry pool instance. And then we're going from pool to mesh. And we're passing our shader program, which has got our texture shader and stuff in it. And the end result is that we have a giant chunk that is textured in our scene. It's amazing. It's only taken, I think I have today, the title says day 16, but I honestly think it's more like day 17. So it's only taken us 17 days. 17 days. To be honest, is not the way I planned it, but it took us a while. But we now have like some building blocks to make a voxel engine. And so really nice things like we can remove, let's see. So we can do some crazy stuff. Like, let's do this. Like, let's do, we'll do if x plus y plus z mod 2 equals 0. Then actually we'll do it like this. That's correct. Yeah. So we actually have a lot of optimization opportunities. I've tried my best, even though the chat gets on me pretty good about avoiding optimization opportunities early. Mainly, I like to build. I mean, just the way I like to generally approach things is I try my best, even though it's very difficult, to not optimize early, because that can limit your options, your API options. It can limit basically your flexibility in general, and so I like to write the nasty version first, right? The version that's just super expensive, and then you can kind of look at performance and be like, well, this thing is actually pretty fast already, and we haven't really even gotten to the complicated parts. So like, it's just going to get faster, and that's a good feeling, because if you have bandwidth to make improvements and get only get faster, then you're going about it in a good way. I mean, that's a general assumption, but that's So let's add something funny, like let's do this. If mod 2 is equal to 0, then let's do block type air. So we're not rendering air block types. This is basically our phony rendering, right? And then this is our fake terrain generation. Right? So you kind of have to consider, like, our little test functions are basically, this is like a really bad terrain generation, and this is like a really bad approach to rendering, and that's it. But again, you know, we're working out the details. We will abstract out the good stuff that we will reuse, and really it doesn't matter what I do. I could do dirt, stone, whatever. It's still always going to be dirt because I'm using this hard-coded UV coordinates here. And then we'll just pass type to here. Boop. So this just give you an idea of, like, this is like a every other block sort of thing. And you're not going to be able to see in there and stuff, but I mean, and this is just with straight up diffuse lighting. Like, this isn't even really complicated lighting here. And we don't have any ambient occlusion at all. Although it does kind of, so we could use the point light or whatever. It does look pretty good with the shadows. Slightly impressed here. It depends. The thing is it's like, you have to look at it like performance is a relative concern, right? I mean, we do this thing at work where it's basically like you build everything quickly. So you want to be flexible and you want to be explicit. And then almost inevitably from that arises performance concerns, almost always. But we pick min specs. Basically, we just figure out, we just kind of throw out spitball, like, hey, what is the minimum hardware we want this to run on? And so we have basically base limitations, and from there you work backwards. It's so much easier to work backwards than it is to try to unravel a pre-optimization. Yeah, I think it would, Marvin. I think it would. I mean, I don't know if it would, but I'm pretty sure it would. Yeah, it's Colt. That's, I mean, in some degree, like, that's sort of what I was trying to say. Like, you can get into a design. I don't think it's a technical problem, and I honestly don't even think it's like. Don't confuse it as what I'm saying as saying that it's a problem to do that, because it's not. This is a practice that I've kind of developed from working in teams over a long time. But if I'm just playing around in sandbox, like trying new ideas and trying certain things, then I'll write it however the hell I want to write it. You know what I mean? There's like, I don't have to work with anybody. If I have to unravel all this stuff, then I don't feel bad because I made the decision to do it. So it's not a bad decision to optimize early. But for this and for this purpose of demonstration, kind of, it makes sense, right, to write it out so it's clear. And then as we move forward, we have optimization opportunities that are just there. So we can use things like the profiler and really see what, okay, well, this piece of code is just dragging ass the entire time. It performs like shit. We really need to optimize this. Versus like, here's something that's a little bit expensive, but it's actually in the long term not costing a whole lot. There's no point in going and focusing that particular other piece of code if it's not wreaking havoc on your performance. Marvin, it can get a little convoluted and difficult. But in general, you're following the right path. Like basically, yeah, we just need we need to be clear in how
Come on, kill me.
we need to supply an API that allows us to do these things cleanly without being too expensive. All right, thanks, Mr. IPQ for the follow, man. I appreciate it. What's up? So anyway, let's try to so we have this so maybe we can do this thing here where we can maybe just cut out every y coordinate. So we could say like if y equals or y mod 2 equals 0 or so here we're cutting out like all our anytime our y is divisible by 2. So this is actually a pretty expensive case for the chunk because you could see it's basically having to render full blocks. There's no neighboring blocks, and so all sides and all vertices have to be rendered for every other row here. So this is a pretty expensive case in terms of actual geometry. Okay. So the good news is it looks like we're building geometry correctly, which is a good thing. Now, next steps. How do we want to translate this into like actually building building a world here? And where do we go from next? Where do we go next? And I don't want to dive in too deep because I only have around 30 minutes left. So maybe let's try some world generator. Let's try to build some things in our main class, just kind of as a scratch pad. Just build out some stuff like this. We already have something that's capable. Let's do this though. I wonder if there's a way we can map types, right? Like this block type, if we can map that to coordinates. That would be kind of nifty, huh? So like we have air, but like what about dirt? I'm thinking that probably we can make our Y actually, to me, it seems like it shouldn't be a problem to add color, because if you've noticed, like our shader can accept color and texture. It seems like we should be able to add in oh, let's not do that right now. We might later. I'm trying to figure out good next steps. So we've already earlier on we built we have this terrain generator with a test noise that actually generates an image. So we can look at this. Basically, what am I doing here? So I'm passing in path and a size. So this is kind of what we're gonna build. Let's invoke this test real fast. This is kind of what we did a few weeks ago or a week ago or so, where we just have this terrain generator. What is that part of? And then test noise, and then we did like noise.ping, and we just leave it at that. And console.writeLine, we'll just say done, and then we'll console.readLine. Okay, so this actually writes out noise to somewhere in here. Bin, probably. Yeah, here we go. So this is basically a noise generator, and this is going to basically give us kind of a height map sort of thing, where the darker areas are going to be kind of our, I mean, you could flip it any way you want to, but the way that I wrote out this noise was to make it clear what the, where like the hills were. But basically we can do whatever here, but the way I have this kind of designed is I think we're going to make the darker regions are going to kind of be our terrain heights, and we're going to scale that to a reasonable value, and then that way we have this nice little height map terrain. So let's maybe try to build some of these things, and this is gonna mean that we're gonna have to probably modify. No. This is what this is, by the way. This is. Sorry, I need to be more clear here. Open simplex noise is to some degree, it's a version. I'm trying to think if I had specific if I had simplex, if I had a good reference for what day that was that we went through this, but open simplex noise is an n-dimensional gradient noise function. Basically, it's all based on Berlin noise. All of it. It's a higher. I mean, this says it all right here. It uses a larger kernel size, but the result is a smoother appearance. It's not as like. Yeah, so the picture is basically Perlin noise. I mean, it's essentially the same sort of thing. This image would, like, you could just set, basically for our chunk generation, we would use something like this. We're going to use an algorithm like this. But all this was doing was writing out, it was just basically tallying up and writing out a pixel, a grayscale pixel of the value versus the height of the chunk, or the height of the voxel at that chunk, if that makes sense. It's just basically we didn't have a chunk data structure. No worries, man. No worries. Please ask questions. I mean, number one, it keeps me in check, and I'm not cowboying off and doing my own thing or anything. Because I mean, I agree. If I was using any sort of other implementation, the only thing is, by the way, this fucking class is ridiculous. And we didn't do a whole lot of profiling, but we did some timing, and it's pretty bad. Like, it's pretty bad. Like, it's like really bad. Yeah, they're slightly different. Yeah. Simplex is actually more expensive. Simplex is based on Perlin. No. I got this guy. There wasn't even a license on it. Let me see if I can find it, where I got it from. I didn't write this at all. This is one I grabbed from somewhere. I think this is it. Refactored for CSharp. This is it. This is the one I got. And oh, he just has a comment on there. And this is free and unencumbered. So yeah, so it's not even a license. You could take it, do whatever. Oh, I didn't even realize that that was the case. But Perlin is also... So what are the limitations to Perlin noise? No, there is a license. It's just a crap license. It's a take it and steal it and do whatever the hell you want to do license. Which is what my entire project is going to be as well, by the way. So anyway, I didn't just so for the record here, this is not something that I researched in depth. This is also something that we can substitute out. So try not to get too caught up. This is crazy. This says heavily optimized version in C#. Yikes. Just bear with me here, because really and truly, this is just something that I think we're going to, I think we're eventually going to, we could substitute this out. No problem. In fact, let's do that. You know what? Let's do that. Let's create an interface. Let's just make this. This will be simple and easy, and call iNoise. We're going to create two interfaces. We'll create one called iNoise, and we'll create the other one will be iNoise Factory. And the entire purpose of the factory will be to implement creation of iNoise. And so we're going to have basically one method on here. Let me correct the namespace here and make this public. And we want, what does this stupid thing have? I guess it's got to evaluate. We'll just say we'll make it for 2D and 3D. We could probably remove the 4D. I don't think it's going to be, we're going to use it for anything here. I'm not even sure that we're going to use the 3D, to be honest, but probably we will. So a noise, we'll give it a public long seed and a getter there. Oh, doesn't need to be public, doesn't need an accessor. And then I guess evaluate, we'll give it a what did that return? What did that thing return? Another double. We'll just make it double evaluate double X double Y, and then we'll give it a 3D. We'll get a 3D evaluation as well. And I'll come back here and comment this. I'm just gonna stub this out, and we'll call this an implementation. If I can spell, implementation prototype for an object capable of creating noise values based on 2D and 3D coordinates. And then we'll have a noise factory. Yeah, Marvin. I'm trying a little bit. I do test a lot of things in the main classes, and then kind of figure out what I want to reuse here. And then, eventually, I like IOC containers, but I think they can make following along a little bit more difficult. So I'm not going that route yet. We may in a bit, but we may go like the ninject route or something like that. But for right now, I think what we're doing is simple enough that we can avoid any of that. Sometimes it's hard for people to even design without an IOC container or something. I just don't want to get in the habit of using it as like a service locator or something. I'm not a huge fan of that. And then we'll just have something that returns an noise we'll just say new generator or new noise. And then we'll pass it a seed. And I think we can do this. This will be fine. And maybe we do a default. I don't know. Yeah, I mean we'll do it like this. Creates a new C iNoise implementation using a date-based seed. Creates a wow. Implementation using the provided seed. Okay. Well, I'll come back and add doc comments for this. The point here is that we probably need, what do I need to do now? What in the blue blazes? Well, I didn't plan on really having this, but I'm gonna have to add, whoops. Just come down here out of the static garbo and just add like a public long seed get. We'll do private set. That private set might not be necessary, but we'll just set seed here to seed. Let's see here. And then I think we can safely implement this now. Whoops. Java. iNoise. Let's add like a separate. And then I'm gonna add a whoops. Open simplex noise factory. And we'll just have this guy. Whoops, I didn't mean this needs to be a class, not an interface. And iNoise factory. And then I think using some code generation. Yes. Wow. And the ugliest code generation imaginable. And then here we can return a new open simplex noise. We can probably change this to, oh, we did. So why is it? And then pass it a seed here, and then just return new. I'm gonna go ahead and replicate this default. There. Wait. Oh, Marvin, it is awful. UI in 3D is Vec4. Hey, how's it going? Sorry, I've been kind of behind. I've been writing some code. I'm not trying to trying to avoid anyone here. I finally got to the functions. I'm not sure I need to test like vec for it. Yeah, I mean, tests are always meh. Don't get me wrong. I'm an advocate for unit testing, but it feels like a chore sometimes. So look at this. So this is that UI specific. This ties into the platform that we're using for the CSharp bindings. And this guy's got stuff. It's actually pretty awesome stuff, to be honest. And you could feel free to look. In the past, I've always used like Scaleform or something like that. Colt, I'm trying to figure out though why though. Why is generating a texture better? Like, you mean ahead of time? You mean like way ahead of time? Like pre-run? Or when? Like, when would I generate this texture? And then the other thing is remember, I'm not building the mesh on the GPU, so passing a texture to the GPU doesn't help me. I would have to basically read pixel values from the texture on the CPU. In which case, I would just ask the question, why go to the trouble to store it in a texture just to read it out later? Unless all the work was done way ahead of time. Right? Like, if I generated a bunch of texture stuff ahead of time, like way ahead of time, and then like dropped it in like a resources folder or something, and then loaded my app and then read from the textures, that would be fast, way faster. I'm just trying to figure out where it applies, or what like how your suggestion would fit. I think it's definitely relevant, and I also think it definitely has merit, because if reading from a texture is clearly cheaper than generating all the stuff on the fly, but in order to get those savings, I would need to do it before, like, I would have to generate those textures ahead of time and sample from them on the CPU. But I still think it's faster than actually generating. Anyway, so we have this so we will allow our terrain generator here. Let's pass in I noise factory. And really and truly, we'd probably end up having to abstract everything so that we had like a terrain generator and a factory for that, and then our noise factory would just pass in an iNoise instance. But because we don't have that level of abstraction yet, let's read only, and then iNoise. We'll just create that from here. Actually, let's not do that. Let's just pass in iNoise directly, because I don't feel like trying to deal with the seed at this point. So I'm going to remove this for now. Not remove, I'm just going to comment it out because it uses that hard-coded stuff. Okay, right. Okay, so Puzzle Dev makes a good point here too, because, well, the idea eventually, and we don't have anything that does this yet, so it's hard to basically say, okay, well, it's hard to make it clear that this would be the case. But essentially, what we would do is we would only generate it once, and then once we generate it, it would be saved to disk. It would be cached in a way, right? Because you only should have to generate that chunk one time, and then you would just save it whenever, number one, it was created, and number two, when it was modified, right? And then every time you loaded after that, it would just pull from disk. It would look to see, do we have any chunk data for the specific chunk, and it would look it up and say, yes, here it is, bam, and it would just load that data and just regurgitate it back into the chunk, versus actually having to generate it. It only has to generate once. And so, like, you would have to, I get what you're saying. You're definitely going to reduce some of the cost, or you're going to spread out the cost is what you're going to do. You're going to end up, if you generated at that point ahead of time, you're not necessarily avoiding all the costs, but you're just spreading them out. You're doing it at a point where CPU is not as important. And so you end up saving in your actual generation by reading from something that's easier to read from versus, in-depth initialization. But this definitely gets filed under, do I really need to optimize that or not, sort of thing. And it's going to be something that I think we need to profile and look at when we get there, not just make the assumption that it's super expensive early on when we're not really that sure of that. So that's just my outlook on this thing. So, terrain generator. What do we need from our terrain generator? We'll get there. You're not wrong. It also depends. You can also create rules using one noise function. Although I know that Minecraft uses a few noise generators to kind of determine things. So right off the bat, the reason why I chose simplex noise, open simplex noise, because out of box it comes with, and Minecraft has a really, really unique way of generating the world, and I think it's really cool. I haven't studied it in depth at all, but I've basically researched kind of how it works, or got a very, very loose summary of how it works, and it's basically like a very cool combination of noise functions and seeds and all of that stuff, and how it, like, tree generation to me is probably pretty complicated. And you see that there's still imperfections in it, because like it will still like generate like a house that's like jammed in the side of a mountain that's like, you know what I mean? Well, Colt, you would only be able to generate, you would only provide a seed once, and then we would use that seed for every time after that. Right. Well, we would have to do it at least once, no matter when we do it. Like, I get what you're saying, but you're also saying the same thing that I am. You're basically saying, you're saying this. user passes seed, generate a bunch of chunk noise in format X. Then, instead of generating noise at chunk creation, read from format X. Okay? This is what you're saying. Here's the difference. Generate, read from. Okay? I'm saying user passes seed as generating while generating world if on disk if on disk read from disk. And then if not, generate save to disk. This is it. This is the same thing, except for this is literally this is all one step. This is generate an entire different format, and then while you're generating, read from that format. Yeah, but you're still generating and then reading from. Versus just, you're still doing the same amount of work. In fact, you might be doing a little bit more work. I mean, here's my problem, is that you're assuming that there's going to be a performance problem immediately. You haven't even seen it. I feel like you've kind of had the same attitude the entire time, that what I'm doing is not going to crawl performance-wise. No, you haven't, because you haven't seen me write it. You haven't seen my version of it. You're making that assumption. Should I pull up the version that only generates on the fly right now? Should I pull up that so you can see that? Let's do it. So here's my proof that you're full of shit. Let's save all this. Play. It's not horrendously slow at all. Oh, I can't jump. Shit. Kind of slow. This looks pretty good to me, man. Keep in mind that you're talking about something that's not related. I keep hitting jump, damn it. Like, this is not reading from disk at all. This is not optimized at all. This is completely unoptimized. There's no reading from disk. It's literally generating the entire time. Everything is generated. This is also got ambient occlusion. It's got a dynamic sky generation that's done completely on the GPU via shaders. My point is that you're making assumptions before they need to be made. And you're saying, oh, it's kind of slow. But what the hell does that mean? What does kind of slow mean? Because really and truly, at the end of the day, all it has to do is run, right? It has to run, and it's good if it performs cleanly and without, like, you know, a bunch of hitching and lagging and stuff. And if I can achieve that, then or if I can achieve that, then I need to figure out how to achieve that. Who cares? Who cares? Like, that's great. But at the end of the day, if you're writing applications for consumer, then I mean, yeah, they might not want to sit and wait for a long time, in which case that's a valuable thing. But like, you're assuming value when you don't even really have any evidence that that value is there. And I think that's a dangerous assumption. I'm just saying. You're basically saying my opinion is that loading this fast makes something superior. And that's complete bullshit. Because again, you can look at something like Minecraft that was written in Java. And one could argue that it's somewhat slow. And it doesn't load all of that shit in less than a second. But the dude sold it to Microsoft for $1 billion. We'll see. So that, in my opinion, is what is a constraint. This is what I talk about pre-optimization being a constraint on your design. You're saying in my case it has to be like this. Well, that's right, because you basically enforced that restraint on your design. Then I mean, that's what I'm saying. Then go for it. If that's what your goal is, then let that be your goal. My only point is that if it doesn't really apply to what I'm doing, like it doesn't, it's not necessarily beneficial. Well, that's great, man. Publish it out there, sell it for $1 billion, and then I'll give you the thumbs up. Because there's this huge fallacy with programmers that believe that if something isn't fucking instant, that it's no good. And I'm sorry, but that's ridiculous. So we want to populate a chunk. No, I know. And then I basically told you why that didn't really apply. And it's like you wouldn't let it go. So just let it go, man. I mean, if you have an argument, then let's debate it. But you're making kind of these claims that don't apply. You're using kind of this opinionated approach to why I should do something, and I just don't agree with you. And you know, you go your way and I'll go mine, and we'll see. You just can't say, well, this is going to be slow. And what, it just doesn't hold any meaning. Like, slow relative to what? It just needs to be productive. We need to keep this productive. And you know, sitting here and back and forth about opinion and approach is irrelevant, because, you know, it just is. It's just irrelevant to this at all. Like, this is what we're going to do. I know that it works. It's going to be fast enough for what I'm doing. So, like, I just don't see. This is actually less. This is actually more complicated and probably more expensive than this. So, what I wanted to figure out, I think I'm going to run short on time. Well, I got about 10 minutes. But what I wanted to figure out based on generating is this. Do we generate the chunks? Probably. I think that's what I'm going to do. From like a from and a to. Like a min location, max location sort of thing. Be based on chunk size, I guess. Yeah, exactly. Because who gives a shit if it's slow, if it's cool? It's exactly my point. Thank you for specifying that. Yes, I feel like that would be neat. You know what would also be neat is if we look at ways to improve it using like actors or a neat programming like asynchronous pattern for automata that would operate in a way that's highly asynchronous and can still apply to our rendering engine, you know, and be designed in a way that has an API that's kind of constructed around the actors versus having to, you know, the number one thing with the actor pattern is everything's got to be an actor, right? I mean, I hate that. I hate that sort of approach to an API. Like, if you want to use our stuff, then everything's got to be this. But it's not true. You can actually abstract out a lot of the actor behavior into like a system. No, I have no idea. I don't even know how to. I don't even. You might be right. I don't know. To be honest. We're gonna see. We're gonna find out. Yeah, we're gonna do testing. I mean, we're gonna profile this bad boy, and I'm sure it's gonna show some very interesting and slow things. Yeah, that's what I was getting with transparency. The other thing is you can switch the you could switch the mode, right? The blend mode before rendering. So I mean, it's like if you mean by alpha, the alpha blending or whatever, and then using so I guess what I'm trying to figure out is this: is that terrain generator? Do we just have a I think a chunk builder. Yeah. What's up, Bo? So I think terrain generator, I guess let's just merge these for now. Let's just call this is going to be our chunk generator. I guess we can return. Did we make our chunk? Did we make our chunk a value type? I wonder. No, I don't think. No, it's a class. Good. Heap. Vec. Whoops. Position. And that's it, right? Yeah. We just need one at a position. Why is it mad at this? Okay, good. So var chunk, new chunk. We'll pass it a position. What did I do here? I think this is all we need here. This is all we need here. How did it do? Where do we start? Max value. I wanted to use the same scale. Do I have a scale X and Y? No, I don't really care. I'm going to use the same scale. I'm going to literally just hijack this, and we're just going to dump it in here. Scale X and Y, octaves. Width is going to be chunk dot width. We're gonna make this chunk dot height. I mean, chunk dot depth. We're gonna do width and depth. Amplitude is gonna be amplitude. We need to reset these values every single time. Frequency. Octaves is gonna be here. And our noise, we're gonna evaluate like this. I think the idea here that what we're doing is we're keeping this value within -1 and 1, I believe. And then we're cutting it in half? No, we're adding 1 and dividing by 2. So we're finding like an average, sort of. We're not going to set pixel. This is going to be our height, actually. Let's rename. Max value is just something I was tallying to see what it was giving me for a maximum. Let's chunk dot width and then chunk dot depth. Scale. This should be scale Z. SZ. And then this should be, oops. We'll call this Z. And then MZ. Really? I didn't even realize that it had lots of problems after Notch left, but I don't think he actually did he actually like leave? Because typically acquisitions they keep you on, but they keep the lead, the hot dog on for a while. Mind test. Okay, so let's start revisiting some of this again. So total, we're going to call this height, because this is what we're interested in. We're interested in the height. And we're interested in height per x at z. This is okay. So this is it. This is where we want. This is where we want to we want to calculate some stuff here. Yeah, 2.5 billion. Jesus, that's a shit ton of money. I mean, dude, it's got to be the highest selling. It's got to be the most expensive piece of software by an indie developer ever. I need to find. I wanted to find how I use this height, because I think we want like a maximum height. What do we want our maximum height to be like? Excuse me. We'll come up with a. We'll just call it max height, and let's just make it like 40 for now. Let's just make it 40. Just gonna put this constant up top. This is gonna be like more. This is gonna be a value from 0 to 1. And so let's just say that the chunk. Let's make chunk set and we're just going to do, oh, we need to actually, let's do uint y is going to be, and then we'll do math. We'll round this height times max height. Something like this, right? So we'll set x, y, and z. I'm actually trying to think here. I guess we would need to iterate underneath it as well. So let's do this, although I'm not crazy about this, to be honest. We're going to call this my, and y equals 0, y is less than. Actually, these need to be relative coordinates, I think. And okay, so I'm screwing this up already, because this needs to be, our position here needs to be in position dot x plus x times frequency. And this can be position dot z plus z times frequency. And then that's how we need to evaluate this. And this actually needs to be I'm trying to think here. How did I do this before? No, I don't think that at all. I just think that you may you just may be a little inexperienced in terms of writing kind of all software. I mean, I'm not saying that you don't know your stuff when it comes to Voxel engines. I think you know more than I do. But there's an overlap there. It's not just about writing a Voxel engine. It's about general software knowledge and how that applies to writing anything. I think you could. I think your knowledge of Voxel engines dwarfs mine. But I'm still gonna call you on general software blunders. I'm trying to figure out. It's not. I mean, it's not even just about formal education either. It's just about. It's about professional experience and just. Listen. I'm not trying to like stand over you and be like, listen to me. I know everything. I'm not trying to be like that. I'm saying that I get it. I understand. I think you're knowledgeable in voxel engines, but I've been doing this for a long time, and if the process that you're suggesting does not fit what I'm trying to do, then they'll get your panties in a bunch that I don't use it or try to defend it, because I'm not attacking your stance. I'm just saying that in this approach, it's not going to work. You don't have anything to prove to me, man. I promise. Like, you don't have anything to prove to me. I'm not even. It's not even a big. It's not even a big deal. I'm literally looking at this in the most scientific way possible and less in the personal sense. Like, the stuff you're suggesting is not super applicable in my scenario. So, and I'm just explaining why that's the case. And then we just you just got to let it go at that point. And if what I'm saying doesn't make sense, then for sure keep asking questions, because there's been things you tried to explain to me before that I didn't quite grasp off the top, and then slowly but surely it's made sense. I think that I want to. All right, I think that I want to. I have this height, and I get a max height. The trick of all this, though, is it less? This is interesting. I feel like I could cache the heights too, as an optimization, because this right now, think about every X and Z. Like, every chunk that's stacked on top of each other will iterate through similarly the same X and Z coordinates. And only the Y will change. And so in that case, if we had already done a chunk and calculated the Y to be something way up here or way down low, then we wouldn't have to calculate it for every single X and Z combination. Here. Y is going to be less than, we're going to go through all these, chunk dot height, and then we're going to plus Y, and we're going to basically, actually this is going to be H, we're going to call this HY. It's kind of redundant, but we need to figure out basically, I don't think we want to scale our Y values. I think our Y values are already output scaled because we've scaled our X and Z. So I think that really what we want is we want to, float my is going to be position.y plus, no. Yes, position.y plus y if it's less than or equal to less than or equal to our HY. Oops. We'll just do this. If my is less than or equal to HY, then we're going to set this. This is what we're going to do. We're going to chunk. Oh, chunk not set. And we'll do X, Y, Z. And the block type will be block type dirt. And else. This is what we'll do at first. X, Y, Z, block type, air. We'll just do air dirt. It wants X. Let's make these uints so that our chunk is happy. Yeah, I mean, this is super expensive. Like, we've got a 4X here. This is 16 by 16, and then this is another inside of that. And then we have the octave loop, which is going to be 6 in our case. So this is a lot of looping. It's okay then. We may be able to do some of this in parallel. And then let's just return chunk. Okay, so let's. For some reason, part of me feels like this is not going to work, but let's just try. Let's just see what we get, and then we can return to it tomorrow. Wow, what the fuck was that? So our create mesh here, our init chunk. Let's do this. So let's move this out of the way. Let's just have our little terrain generator here. Terrain generator equals new terrain generator, and then we'll pass it this directly right now. Open simplex noise. Let's use a explicit seed here just to ensure we're getting about the same stuff. I'm gonna leave the defaults, and then let's just generate some damn chunks, you know what I'm saying? Oh, we just returning this, man. Just return this straight up. Oh. Well, actually, we just set it, don't we? Chunk equals. Hey, look. It generated a giant cube. Not surprising. Let's see what it's giving me for these values here. Let's add a breakpoint here. And then let's move. Let's see. Step over. So our HY there is 20. Oh, that's why. I mean, we probably want to take advantage of maybe let's keep this smaller. This max height. I think let's remove the breakpoint. I think that's what the deal was. Well, no. Oh, yep, there we go. Some rain. Wow, yeah, that's busy. See, this is a little too much, maybe. A little too noisy. Let's look at maybe some better scaling. Let's use like, I think actually maybe the smaller the better here. This might actually generate some more turbulent noise. Oh no, this is smoother. Okay. So we're taking the same noise function, we're just scaling it a little bit. We're spreading out the smooth. Yeah, those are features. That's what I call them too. I still don't like it. I don't like shit like this. This is weird to me. This is odd. This shape that it created. God, without ambient occlusion, man. Like, this is a weird shape. But what are you gonna do? Let's actually set like max height to like 12. I need to make max height something that we pass in. This is maybe a little nicer. I mean, in the end, the bigger your scale, the more detail you're going to get. Yeah, I'm using like 6 octaves. But you also got to remember here that I'm only generating one chunk, and I'm trying to constrain the values of the noise within that chunk so that I can actually see the effects of it. And so that's probably causing some issues as well, at least in terms of like consistency. Anyway, I'm a little bit over for today. This has been a pretty long ordeal. Let's see. Let's see if we can just show that we can interconnect some things. And again, this is not optimized at all. So, let's do like, let's maybe do like a list of chunks. And then we'll do list of renderables too. Meshes, chunk meshes. So let's just kind of move through some of these. Let's just like, we'll do list.add. Well, we could probably generate like 6 of them. For uint x equals 0, x is less than three, I guess. Well, we could do 9. We can do 9 of them. Plus x. And then for uint z equals 0, z is less than 3 plus z. And then let's just generate we'll do 0. Oops, we'll do x, 0, z. And then list.add. I mean, this is going to be expensive, but it's fine. And then we'll return list. And then we'll accept a list here. And return a list of renderables. Whoops. And then let's add one more giant for loop out here. Just to make it a little bit more inefficient. Oops, for each. That is a dandy for loop if I've ever seen one. So what we're gonna do each iteration here, let's add this. We need to add a renderable and pool.toMesh. That's right. And then Then we need a pool.reset. We need to reset our pool each time. Oops. We'll do init chunks. Chunk meshes, and then we'll do chunks equals init chunks. There we go. And then when we actually render these things, we'll do another for each. Renderable in chunk meshes. And then we need to render all the meshes. Whoops. Renderable. Of course. Oh, dang it. Or each var chunk mesh in chunk meshes dispose. Look at that shit. Something went terribly wrong there. What in the fuck happened? Look at that. That is some fucked up stuff going on right there. Yeah, I'm not gonna have time really to debug this. I thought this would give me a nice little what am I missing here? Oh, derp. Oh, I need to just make it chunk dot width depth. This is world space coordinates. Oh, it still made that weird fucking thing. Is this actually? It's got to be right. Is my set not right? Yeah, it's got to be. Yeah, setting actually creates it correctly. Yeah, you know, I'm not quite sure why this isn't working. But we're going to have to figure it out. It's creating this weird shit down here. Which just, like you could see the lag. It's making my GPU freak the fuck out. Well, we get 1 at 0, 0, 0, and then, well, did we get our positions are right? Huh. Let's I'm gonna look at one last thing here. The Abyss Horizon. Yeah. Roundish voxels. Because I believe our vertices were actually creating. We don't need to translate this. The object is just the backing. It's almost too, like it's too much. I'm gonna put a break. If I can put a breakpoint here, yeah, let's do that. Let's put a breakpoint here, and what I'm interested in is the chunks list. Here we go. Let's look at these. Yeah, I mean, these are right. All of this data is right. Hmm. So this raises the question, what if I just return new list chunk and then just pass generate, and we'll pass it. Let's just do like the one at new vector 3, and we'll do 0 0 16. Wait, what? Oh, there you are. So that works. So what if I just add to this? If this works, I'm going to freak out. You got to be shitting me. Oh, yeah, there it is. It's gone. What in the fuck is going on down here? Is that the positive space? Like, this is crazy to me. Why is this a problem? So if I generate 1, it's fine. But if I generate 2, it seems to indicate that there's a problem with this pool. Doesn't it? But we're clearing everything out. No, we're not. This is why. This is why, kids. That's why we're getting junk down there, because it was junk indices values. Okay, let's go back to our regular. Let's go back to this. And then we don't have to dump that out anymore. Okay, here we go. Hey, it's not very pretty. And the noise generation definitely needs some work. But you see how all the chunks very nicely fit together. You get a nice continuous flow. And let's just glance. Hold on. Let's just glance at our memory here. What are we at? 81 megabytes? That's not bad. Huh. Okay, well, yeah, I mean, again, this is not the prettiest thing in the world, but I've reached a milestone. I'm going to take a screenshot. Remove up the streaming. All right, guys. I have to get to work. I'm like almost 30 minutes late to work today. So I'm going to be at the office for a long time, but it was worth it. And thank you guys for tuning in for sure. We'll keep this going tomorrow. We're starting to make finally some progress into Voxel's creation and stuff. And, you know, again, there's plenty of room for optimization here. I mean, like these are gross, giant for loops. And to some degree, we might be doing some of this, like especially this. But keep in mind that we'll always be doing this on a somewhat of a small scale. Chunk width and chunk depth and chunk height are going to be, you know, at max, this is about 4,096, I think, is the 16 by 16 by 16 iterations. This is absurd because right now, not only are we rendering those chunks that you could see from the outside, but all the faces. Let me just show you. I could show you is that if I dive in here, look, there are faces on all of this geometry. Like, that is ridiculous. Like, there's no reason why we should have that. So you want to talk about like hitting some easy optimizations early. That's one that we're going to absolutely do. You know, if we can't see. The other thing we need to look at in a bit is frustum culling. So if my camera is looking around and if I look over here, there's no reason we need to be rendering the chunks that are not on screen. That's another thing. So we'll look at all of this stuff and how it applies. And that'll be tomorrow, hopefully. We'll be able to look at some optimization stuff. But we're getting into the actual fun part. So hopefully you'll come back tomorrow and hang out. Anyway, thanks again, guys. We'll talk to you soon.